All right, what's up, y'all? It's me. Hello, YouTube. It's Mr. Cordero. We out here. I'm about to do this Unit 7 study guide. I'm going to do it in order. So if you only want like question 18, then skip ahead to question 18. I'm just going to do the problems in order. Okay, so this first one is really easy. This one's just your name. So everybody will have different answers for this one. Mine is Mr. Cordero. Yours might say something different if you have a different name. That's fine. This next one is like kind of like separated in by section. So first thing we did was negative and zero exponents. These are all just like basically like simplifying things only, like no multiplication or anything. So okay. The way these work is you go into, you go just factor by factor, and then you see if you can do anything with any factor. For example, this is a 2. I don't see any other numbers, and I don't see this 2 being squared or raised to a negative power or anything, so that's just going to stay a 2. X to the 4th, similar thing. That's going to stay x to the 4th because there's no other x's to combine with, and this isn't raised to a negative power, so I can't take x to the 4th. Like I can't make that a 32 or whatever. Okay. Next I go to the y to the negative 3, and this one is raised to a negative power. That one is the first one I can do something with. The negative, remember, means flip it, like put it on the bottom of a fraction, y, and then make the exponent positive. Y to the 3rd on the bottom, and then z to the 0, remember anything to the 0 is just 1. So I could put a times 1 up here, but that is, well, let's just do it. Your answer might look something like this. That's fine, but also like 1 times anything is just itself. So this is like a more normal way to write that answer. Sorry, my thing is crooked. I have looked to like, well, you can see right here, I have the camera set up on a speaker, and so I'm like, have my arm around the speaker, so it might look kind of crooked. Okay, this next one, 5 to the negative 2nd, not much to do here other than like, okay, 5 to the negative 2nd just means flip the base, make the exponent positive. That's 1 over 5 squared, which is 1 over 25. If on the test you forget like what 5 squared is, then just leaving it as 1 over 5 squared, I'm going to say that's okay for now, especially since these numbers can get pretty big and you don't have calculators. I'm trying to get this to focus. Yeah, I don't know how to do that. Maybe what if I turn it off and on? All right, focus. All right. This is the same problem I have in class, just getting my students to focus. Now it's a camera. I'm trying to get my camera to focus. All right, well, whatever. This is 1 over 25. Negative 3 squared. Notice that this is an entire thing, all of negative 3 squared. In other words, that's negative 3 times itself. That's why this will be a positive 9. Negative times negative is positive 9. All right. This next one, 17 to the 0th. Remember, we just said anything to the 0th is 1. So that's your final answer, is just 1. Okay. Try and move this. Yeah, okay, then that's focusing on the right thing. All right, the next one. Same thing as before. I'm just going factor by factor and seeing what I can do to each factor. So 2 to the 3rd, there is something to do here. 2 to the 3rd, I can simplify. That's just 8. 2 times 2 times 2. Don't say it's 6. Okay, a to the 10th. Not much to do there because there's no other a's down here. There's no other a's to combine with. This is just a to a positive power. Nothing to do there. That's just a to the 10th. Then c to the 7th. Same thing. No other c's. Nothing to combine with. That's just going to stay c to the 7th. D to the negative 8th. That's something that I can do something with. Since it's a negative power, it's a negative power on the bottom of a fraction, so it flips and it goes to the top of the fraction. and the power becomes positive. And then b to the 12th, nothing to do with that. B to the 12th stays. Okay, so there's your answer there, and that's how I got it. All right, next one. -6 squared. Now notice this, that's different from the one right above it. This one is -3 squared. This one is -6 squared. Hopefully you hear the difference in that. What this one means is square 6 and then make it negative. Another way to see this would be like -1 times 6 squared. You can see the squared is only with the 6, not with the -1. Anyway, this will be, well, 6 squared is 36, so negative that would be -36. Cool. All right, there's section 1. Section 2 is all about multiplication. So in this one, I mean, it's a similar pattern where you go factor by factor and you see what you can do to each factor. For example, I got, starting with this 6, I'm looking for, can I do anything with this? And the answer is yes, because I see another number right here, 6 times 5. And then how do these combine? Well, I just said it, it's multiplication. So 6 times 5. These are normal numbers like we know and love from 3rd grade or whenever you learn multiplication. 6 times 5, nothing crazy there. That's just 30. And then, okay, I've dealt with the numbers. Now I go to the k's, and I have k to the 3rd times k to the 11th. Remember, with exponents, these are the weird rules, where with the exponents, multiplication becomes addition. So k to the 3rd times k to the 11th becomes k to the 14 because 3 plus 11. Nice. All right, next one. All right, similar thing, go factor by factor. I see an x here. Any other x's? Yes, right here. How are these combining? Oh, they're being multiplied, therefore I add the exponents. Okay, so x to the 8 times x to the -3rd should be x to the 8 minus 3 is 5, or 8 plus -3 if you like that. Anyway, then I've dealt with the x's, so now I go to the y's. Y to the 10th times y should be y to the 11th. If you on your answer key or your like worksheet you put y to the 10th, you should be ashamed of yourself. No, I'm just kidding. But remember that this is y to the 10th times y to the 1st. So this is 10 plus 1 is 11. Okay. Next one. 7a to the whatever times 4a to the whatever. Okay, so same pattern. Go factor by factor. I see a 7. Anything I can do with that? Yes, there's another number here it can combine with. Okay, 7 times 4 is 28, because those are just normal numbers. Those are the coefficients, they just multiply. Dealt with the numbers, now the a's. A to the 10th, any other a's? Yes, a to the 3. A to the 10th plus a cubed, or times a cubed, will be 10 plus 3 is a to the 13. All right, hopefully this is focusing, you can read this. I've dealt with the a's now b's. B to the 7th times b to the 3rd. You add those, you get b to the 10th. Dealt with the b's, and then there's a c to the 3rd that I can't do anything with. There's no other c's. This isn't raised to a negative power or a 0 power. That's just saying c to the 3rd. Nice. All right. Next one. 11x times 3x to the 5th y to the 7th. Same thing. Go like factor by factor. First the coefficients. I see an 11. Here's another number. These can combine how? Oh yeah, they're being multiplied. So 11 times 3 is 33. Dealt with the coefficients. Now the x's. X times x to the 5th is x to the 6th. Again, if you said x to the 5th, you should be ashamed. Okay, dealt with the x's. Now I still have a y out here that I can't do anything with, so that would just be times a y to the 7th. Nothing to do there with the y. Nice. Okay, next one. Similar thing. Now we just got y's though, so this is y to the 18th times y to the -20th. I add those two. 18 plus -20 is the same thing as 18 minus 20, which is y to the -2nd. Is focused. Come on. All right, y to the -2nd. And then y to the negative second is the same thing as 1 over y squared. In your final answers, you should never have negative exponents or fractional exponents or 0 exponent, like an exponent of 0. That's not as simple as you can make it. All right, and then 12 is just a smiley face, so we'll make this into, I don't know, make this into a person ice skating because of the Olympics. Nice. Okay, there's my little person ice skating. Okay, next one is, this is all about division. Okay, so notice the difference real quick between these guys, this type of problem, and problem number 5 up here. The difference between these two fractions are that, look, problem number 5 just has a number and no number down here. An A and no A down here. C to the 7, no C up here. No D up here, no B up here. Whereas this one, most of them will be like coefficient, coefficient, x, x, y, y, on the top and on the bottom. So that's how you know one problem from the other. Okay, so division works like this. You treat the coefficients like a normal fraction, just like everything else. Like we treated the coefficients with multiplication normally, we multiplied them. Same thing with division. So if I got the fraction 14 over 7, I would know that that simplifies to 2 over 1, or just 2. Okay, so my final answer should have a 2 on, or a 2 over 1, if you like that. All right, then I've dealt with the numbers, now you deal with the x's. X to the 8th over x to the 2nd. Well, if multiplication is adding the exponents, then division should be subtracting the exponents. So here's me doing that, x to the 8th minus x to the 2, or well, over x to the 2nd. I subtract the exponents and get 8 minus 2 is 6. The bigger number was on top, so my answer should go on top. That's how I think of it. You could also always think of it as top minus bottom, and then if it's positive, your answer goes up top. If the answer is negative, then it goes on the bottom. For example, here with the y's, I see 6 minus 12. That is going to be negative 6, so that y to the 6th power goes on the bottom. Okay, that's how some people like to do it. The way I think of it in my brain is I always just do big number minus little number. So like, for example, 12 minus 6, that's 6. And since the bigger number was on the bottom, my answer goes on the bottom. Okay, so there's one. Next one, similar thing, 9 over 3. If I got that as a normal fraction and it said simplify, I would simplify this to 3 over 1. Or just 3. Okay, then I do the x's. Here you have a little bit of a choice. The most consistent thing, I think, is just to do top number minus bottom number. -1 minus 4 is -5, so that would be an x to the 5th on the bottom. The other choice, if that doesn't you don't like doing that, then the other choice is to do, since this is a negative exponent, you could bring it down here. This is a little bit more complicated, but this is what you could do. You could take this negative exponent down to the bottom, be left with 9 over 3 x to the 4th times x to the 1st. And now you got 9 over 3 is 3, and x to the 4th times x to the 1st is just like these problems up above. So that would be 4 plus 1 is 5. Okay, so either way you do it, same thing. I'm going to erase this to not confuse kids on the key that I post on Schoology. Okay, either way you should get 3 over x to the 5th. Nice! Alright, next one. Same thing as all the other ones. Deal with the numbers first. So here's a 5, here's a 25. You deal with that as a normal fraction. 5 over 25 is 1 over 5. Okay, so that's how you would simplify it normally. So my final answer should have a 1 over 5. All right, then you deal with the letters or the variables. 8 to the 4th over 8 to the 9th. You subtract these. 9 minus 4 is 5. The bigger number's on the bottom, so that goes a to the 5th. Again, the other way is just to always do top minus bottom. 4 minus 9 is negative 5. Since it was negative, the answer goes on the bottom. Okay. B to the 10th over b should be b to the 9th. If you said b to the 10th, you should be ashamed of yourself again. Again, that's because this is a b to the 1st implicitly, like even though the 1's not there, that's implied. And then okay, and then you subtract the 10 minus 1. Okay, then again, same thing here. You got a c to the 1st over c to the 3rd, so 3 minus 1 is 2, and that goes on the bottom since the bigger number was on the bottom. So here's a good answer, except it's kind of weird to do 1 times anything, so it's just more normal to get rid of this one. This is like a cleaner answer, b to the 9th over whatever. Okay. Next, this is my cat, Reggie. Okay, next 16. Here he is again. 16 goes like this. I look at the coefficients. I see a 4 over 6. If I got that as a fraction, I would simplify it to 2 over 3. Okay. I know that the camera is not really focusing. Oh, shoot. Okay, how's this? That's okay. Yeah, all right, that's fine. Okay, so 4 over 6 simplifies to 2/3, so that should be in my answer somewhere, 2 over 3. Okay, then I have u to the 7th over u to the 1st. 7 minus 1 is 6, and the bigger number's on top, so that's u to the 6th. V to the 8th over v to the 1st. 8 minus 1 is 7, bigger number's on top, so my answer goes there. So that's your final answer for 16. Okay. 17, oh, 17 is a nice one. Just 22 minus 19. You get x to the, what is that, 3? Yes. X to the 3rd. Okay. Then last one, I see a 2 over a nothing. Remember, that's just an implied 1. So if I got a 2 over 1, that would not simply, I mean, that's the simplest you could make it. So that stays a 2 over 1. That should be in my answer somewhere. Then I got x to the 5th over x to the 7th. You subtract these, either always do top minus bottom or do my little trick, which is 7 minus 5 is 2, and the bigger number was on the bottom, so x to the 2nd is on the bottom. Okay, then y to the 2nd over y to the 9th. 9 minus 2 is 7, the bigger number is on the bottom, so that's where my answer goes. Cool. All right, next one. Ah! Okay, next is power property. This is a kind of a recent thing that we've done. This is this is raising powers to powers. Okay, so what do I mean by that? Look at this first one. 3x to the 5th all squared. The way these work, remember, just like with everything else, the coefficients act normally. You do what the problem tells you with the coefficients. So if it says 3 squared, then you do 3 squared. And then the weird part is with the exponents just get multiplied. So this would be 3 squared times x to the 5 times 2 is 10. All right. So that's a good answer. You could leave it like this on a test, but you should know what 3 squared is. 3 squared is 9, and then x to the 10th. Cool. Okay, that's the same thing for all of these. So all of these should be very, very similar. Now I've got this entire thing being cubed. So, okay, numbers act normally, so the coefficient is 4 cubed. Okay, 4 cubed. I'll deal with that later. Then x to the fourth cubed, that means multiply these. So x to the 4 times 3 is x to the 12. And then y to the 8 times 3 is 24. Okay, and then this is an okay answer, but 4 to the third is 4 times 4 times 4, which is 64. Okay, and then this is a better answer. Okay. Next. Well, I mean, it's a similar thing. R to the 10th, S to the negative 11th, all raised to the 7th power. Here I have no coefficient, so I just have to worry about multiplying my exponents. Okay, R to the 10 times 7 is R to the 70th. And then S to the 11 times 7, well, negative 11 times 7 is negative 77. Okay, and then this is a negative exponent. You don't want those in your final answers. Negative exponents get put on the bottom and become positive. So your final answer should look like that fraction. All right. Next one, 22. Looks like 2n to the 8th to the negative first power. There's a couple of ways to go about this, but let's just be consistent and do the same thing as we've been doing. The coefficient just gets the power 2 to the negative first, and then the exponents get multiplied. So n to the negative 8th. Okay, and then this just means flip the 2, flip the 8, and make the powers positive. So 2 to the first if you want, but 2 to the first is just 2, and then n to the 8th. Nice. Next one, same thing, 5 to the third power, because the coefficients act normal. Then x to the negative 7 times 3 is x to the negative 21. And y to the 9 times 3 is y to the 27. Okay, then 5 to the third is 5 times 5 times 5, which would be 125. X to the negative 21st, since it's negative, it can be put on the bottom of a fraction. And y to the 27th just stays the way it is on top. Okay, so there's that. I think the speaker is what makes it unable to focus. Maybe if I block this. I don't know. Anyway, 24 is just an avocado, so you can do whatever you want with this. Let's just add some chips. There you go. Tortilla chips. Next is rational exponents. This is the last thing we learned. And a lot of people were like very sad about these, but they're not very hard. All you have to do is the following. If you get x to any fraction, and then the bottom of that fraction is going to be a root, meaning this will be the cube root of, and then it'll be x to the, this will be the power. So cube root of x to the first. Okay, now this is a weird way to just write the cube root of x, because x to the first is just x. So this is a more normal way to write that, but if you left it like this on the test, that's fine. Okay, y to the 2/5. Okay, y to the 2/5, same exact thing. The bottom of it will be a root, so 5th root of, and then y squared, y to the top number. That's a 2, the y squared. Okay, 5th root of y squared. And remember, all this means is what number times itself 5 times will give me y squared. Okay, next, 3p to the 4/9. Notice, only the p has the 4/9. This isn't in parentheses. Not like that. It is without the parentheses. So 3p to the 4/9 means the 3 is just left alone. There's nothing to do with it. And then p to the 4/9 we treat like this. So that would be the 9th root of, that's a 9 by the way, 9th root of p to the 4th. Okay. Next one, this one is different because this one, the entire 2x is being raised to the 6th power. That's what these parentheses are doing, or sorry, to the 1/6. So that's what these parentheses are doing. So this entire 2x will be inside of a 6th root of 2x to the first if you want, but 2x to the first is just 2x. I'm going to leave it like that. Cool. Next one, 3 to the 2/7. Same thing. Don't get confused because it's not a variable. This is still the same thing as the 7th root of 3 squared. You could leave it like this if you wanted, but 3 squared is the same thing as 9. So this is the 7th root of 9. Either way is fine on a test. I don't care. Okay, then 30 is just a baby. So I don't know. Make the baby maybe breathe fire. There you go. Baby's breathing fire. All right, now everything together. I'm guessing most of you guys will just be watching this part of the video. So, yeah, okay, let's go through these. The first part, or the first problem in this, it looks like that. And you'll notice, like, what I see when I see this is like something times something, and each of those somethings are like an expression raised to a power. So according to PEMDAS, like order of operations, you should do parentheses and exponents first. Okay, like as in exponents before multiplication. Okay, so let's do these exponents. Let's deal with these guys, and then we'll deal with the multiplication. All right, so this, if you just got that first part, that would be easy. Like you just did a bunch of examples up at the top of this page right here. Okay, so you do the same thing. Don't get confused because now you have to do it twice. You just do it in the same way. So 2x to the 7th all cubed would be 2 cubed, which I'll deal with in a second. X to the 7th cubed, which would be x to the 7 times 3 is 21. Okay, there's the first expression times the second expression, x to the -2 to the 4th. That is x to the -2 times 4 is -8. Okay, and now it looks like something we did on the front side of the page. Sorry. Okay. What I'm saying is now this looks like a multiplication problem where we've got something times something else. These are both x's, so you can add the exponents. So I've got 2 cubed, which is just 8. And I've got x to the 21st times x to the -8th. Multiplication turns into addition for exponents, and then that goes 21 minus 8 is 13. Nice. Next one, next one's not that bad. We got x squared times x to the 1/2. So this will be, I mean, it's multiplication, so you add the exponents. I've got x to the 2 plus a half is 2.5, which is easier to write as a fraction for this. So 2.5 is the same thing as 5/2. So you got x to the 5/2, and then it says don't leave any fractions as exponents. Okay, so that means turn it into a root like this, like you did up here. So this means the square root of x to the 5th. Bottom is the root, top is the exponent. This is a fine answer, except nobody writes square root like with a little 2 out here. So it's just more normal to leave it as just square root without the little 2 out here, x to the 5th. These both mean the same thing. This one is probably more normal, like it's a better answer. Okay. Next one. 2x to the -3rd, or sorry, 2xy to the -3rd squared times this stuff. It's very similar to the first one, the 31 over there, where I've got expression times expression, but one of these has an exponent, so according to PEMDAS, do the exponent first. Okay, so let's deal with this exponent. I've got a whole expression squared. All that means is I square the 2. 2 squared is 4. Okay, 2 squared. Then you deal with the x's. Everything gets this power, remember? So x squared, because 1 times 2, that's an implied 1 right there. Negative 3 times 2 is negative 6, so y to the negative 6th power, which I'll deal with later if I have to, like in terms of flipping it and everything. Okay, then times this that we did not mess with, 3x to the 4th, y to the negative 4th. Okay, so first step done. Then second step is to do the multiplication, because, I mean, there's still more to do. I see a number, I see a number, those can combine. I see an x, I see an x, those can combine. You shouldn't have more than one, like, of each factor. Like, you shouldn't have more than one x in your final answer, or more than one y in your final answer, because they can combine. Okay, so 4 times 3, just like we were doing on the front page, is 12. X squared times x to the 4th, remember multiplication becomes addition with exponents. And then y to the negative 6th plus y, or well, times y to the negative 4th. You add those, you get y to the negative 10th. But you can't leave negatives as your final answer on the exponents. Negative coefficients are fine, but negative exponents are not. So you fix this by making this y to the negative 10th a fraction, putting it on the bottom. So this would be 12x to the 6th over y to the 10th. And that's your answer. Okay. I can see that that's not really focusing, but hopefully, like, you can read it. All right. Next one, this is, well, I mean, you got to figure out what it is. Is it division? Is it, like, simplification? What is it? In this case, I see an x on top, x on the bottom. Oh, that means I'm, like, dividing these. In other words, I'm subtracting the exponents. Okay, so let's do that. I see x to the negative 2nd over x to the negative 3rd. Negative 2 minus negative 3. Let me write that out so you can see what I'm saying. Negative 2 minus negative 3. That's just minus a negative, so that's going to be negative 2 plus 3, which is 1. Okay, so my exponent ended up positive, so that's going to be an x to the 1st up top because it's positive. And then notice, okay, this 3, there was nothing to do with it. This was just like a 1 over 3. So that 3 is going to stay put where it was. And then this y to the negative 2nd, there's nothing to, like, combine it with, but it's still a negative exponent. So I don't want to keep that. You don't want to keep negatives in your negative exponents in your answer. So you could write a y to the negative 2nd here, but then you'd have more work to do. Y to the negative 2nd becomes a y to the positive 2nd after being flipped to the top. So this is your answer. That's kind of weird to have the 3 out there. So let me put it in a more normal place. There it is. Okay, next one looks like a combination of division and exponents. According to PEMDAS, I should do exponents before division. I'm going to simplify this expression squared and then do some division. Okay, so if you just got the top part of this, you would say, oh, okay, this is no big deal. I did it at the top of this page. Up here is where you were doing all that. Okay, so don't think of this as any different. This is the same thing. So I've got, I wish this would focus. Sorry, you guys. Okay, so I've got, remember everything in the exponent in the parentheses gets the exponent, so this would be 6 squared, which I'll deal with in a second. A to the 7 times 2 because the exponents get multiplied here. So that's a to the 14th. Then b to the 2 times 2, that's b to the 4th. Over 4a squared b. Okay. Then I've got some simplifying to do because 6 squared over 4 is just easier if I know what this number is. So 6 squared is going to be 36, and then everything else I'm leaving alone for now. Okay, and then now you can do the division just like you were doing on the front page. So this says 36 divided by 4. 36 over 4 is 9 over 1. Like if you just got this fraction, just 9 over 1. Just because 36 divided by 4. Okay, that's 9. A to the 14th over a to the 2nd, you subtract these exponents, you get a to the 12th. And then b to the 4th over b to the 1st is b to the 3rd on top. Over nothing, over 1. So actually, you don't even need this fraction line. I'm just going to use it as part of my circling. And there's your answer. Okay. Last one on this row. Looks like a combination of multiplication and division. So before I can divide this, I should simplify the top first, because technically there's an implied set of parentheses up here that's like grouping that together. So I should do that first according to PEMDAS. Okay, so let's do it. I got x times 3x. Okay, well, these x's can combine and become x to the first plus x to the first becomes x to the second. Then I got a y cubed that's not combining with anything, at least on the top. Y cubed can't combine with any other y's on top. That's just y cubed. And then I had this extra 3 that I can't do anything with yet. That 3 is going to stay a 3. I'm going to write it up front because that's more normal. Okay. Next. I did not mess with anything on the bottom, so that's still there. Okay. Then this becomes 3 over 6. Okay, 3 over 6 is just 1 over 2. X to the second over x to the 5th. 5 minus 2 is 3. The bigger number is on the bottom, so x to the 3rd. And then 3 minus 3 is 0. So that's going to be y to the 0 up top. But you don't want to leave any zeros as exponents. So y to the 0th just becomes a 1 like we know, over 2x to the 3rd. Okay, and there's your answer for that one. All right, last row. This one is a similar one to 35, except now the exponent's on the bottom. So according to PEMDAS, you should do the exponent first. So let's do that. Top I'm leaving alone. The bottom I should make, well, okay, 2 squared, which is 4. X to the 2 times 2, the exponent's going to multiply it and become x to the 4th. And then y to the 2 times 2 becomes y to the 4th as well. Okay, now you're simplifying this. I've got technically a 1/4 there. So for the coefficients, this fraction does not simplify 1/4. So that should stay a 1/4 in my answer. Okay, x to the 0 over x to the 4th, I should subtract these guys, and it becomes 0 minus 4 is -4. That is an x to the 4th, therefore, on the bottom. All right, and then the y's are y to the 3rd over y to the 4th. 3 minus 4 is -1. That's a y to the 1st on the bottom. Another way to do it, like I keep saying, is to do 4 minus 3 is 1, and the bigger number is on the bottom. So your answer goes on the bottom. Okay, there's that one. This one's only tricky because we haven't seen this many negatives, I don't think, in a fraction. But it's the same thing. This is the same thing as an implied 1 out here. So I've got the fraction -3 over -1. Okay, if I just got this fraction, then that's just a negative over a negative becomes a positive, so 3 over 1. So my answer should have a 3 over 1. I'm just going to leave the 1 implied down here. Okay, then I got x squared over x. That should be x to the first because 2 minus an implied 1 here. 2 minus 1 is 1, so x to the first. And then y squared over y, same thing. That would be y to the first. Okay. Then there's nothing else to do, so you circle this. It is kind of weird to keep it as x to the first and y to the first instead of just x and y. So I'm going to erase these ones because that's kind of weird. This is a much more normal way to write the same thing, 3xy. All right. And then last one, that just looks like a multiplication one, no fancy exponents, no, I don't know, fractions, no division. This is just a straight up multiplication one like you could have done on the front side of the page. So you treat it like that. Okay, I got 3 times 4 is 12. Dealt with the numbers. I got x to the 0th times x to the 12th. That becomes addition with the exponent, so that 0 plus 12 is 12. And then y to the negative 13 times y to the third. You add those and you get y to the negative 16. Nice. But I have a negative exponent. You don't want to leave those in your final answer. Negative exponents just get put on the bottom, and you're left with 12x to the 12th over y to the positive 16. And now you smile because you're done with the whole thing. Okay, I hope this was helpful. I hope you guys get something out of this. I hope that the camera is like focused enough for you to read this. Good job, keep studying, and great luck on your test.